Welcome to Spaceverse, your portal to cosmic adventures. What happens when a star the size of Jupiter starts acting up? Betelgeuse, one of the most famous and fascinating stars in our night sky, is currently undergoing changes that have astronomers both puzzled and excited. This isn't just any ordinary star, it's a red supergiant, one of the largest types of stars in the universe. To put its sheer size into perspective, if Betelgeuse were placed at the center of our solar system, its outer layers would extend well beyond Mars, potentially reaching as far as Jupiter's orbit. That means it would engulf not just the inner rocky planets, but also the asteroid belt and a significant portion of the outer solar system. This colossal star has been behaving in ways that challenge our understanding of stellar evolution. Over the past few years, Betelgeuse has undergone unusual dimming events, sparking speculation about whether it's nearing the final stages of its life. Some scientists believe this variability is caused by massive ejections of gas and dust from its surface, temporarily obscuring our view. Others suggest that it might be experiencing internal convective changes, where hot plasma is shifting unpredictably within the star. Whatever the cause, Betelgeuse continues to captivate astronomers, as it provides a rare opportunity to study the late-life behavior of a dying star in real time. For centuries, Betelgeuse has captivated stargazers with its deep reddish glow, a striking presence in the constellation Orion. As one of the closest red supergiants to Earth, it has long been a subject of fascination, especially because it is in the final stages of its stellar life. However, something unusual has been happening. Betelgeuse has dramatically increased in brightness, becoming over 50% more luminous than before. This sudden surge has propelled it from the 10th brightest star in our sky to the 7th, a significant and unexpected change for a star of its kind. Could this be a sign that Betelgeuse is gearing up for a spectacular supernova? Or is this just another one of its dramatic mood swings? To find out, we need to dive into what makes a star shine. A star's brightness depends on its size, temperature, and distance from Earth. And Betelgeuse? It's a true heavyweight, over 700 times the size of our Sun. But despite its size, it's surprisingly cool for a star, with a surface temperature of around 3,000 to 3,500 Kelvin, giving it that fiery red glow. So is Betelgeuse about to go out with a bang? Or is it just reminding us that space is full of surprises? Stick around as we explore the mysteries of this cosmic giant. For thousands of years, Betelgeuse has mesmerized civilizations across the globe. The ancient Egyptians saw it as a celestial link to Osiris, the god of the underworld, while the Greeks tied it to the mighty warrior Orion. These myths prove one thing: Betelgeuse has always been a star of legend, and today it's making history once again. Right now, astronomers are watching this colossal red supergiant with growing anticipation. Could we be witnessing the final moments before a spectacular supernova? If Betelgeuse does explode, it would be a once-in-a-lifetime event, so bright it could outshine the full moon, casting shadows on Earth and even being visible during the day. But is this the ultimate cosmic finale, or just a dramatic mood swing? To answer that, we need to look at the life of a star. Stars, much like living things, are born, evolve, and eventually meet their end. They start as swirling clouds of gas and dust, gradually pulled together by gravity to form newborn stars. Inside, nuclear fusion ignites, turning hydrogen into helium and fueling the star's brilliance. Over millions of years, stars like Betelgeuse burn through their fuel, fusing heavier and heavier elements until they can't sustain themselves any longer. Right now, Betelgeuse is in its final act as a red supergiant. Whether its sudden brightness is a prelude to an explosive finale or just another twist in its long life remains to be seen. One thing's for sure, whatever happens next will be a cosmic event for the ages. When a star as massive as Betelgeuse reaches the end of its life, things get wild. After burning through its fuel, the star swells into a monstrous red supergiant, so massive that its outer layers are barely held together by gravity. At this stage, Betelgeuse is like a ticking time bomb, destined for one of the most powerful events in the universe, a supernova. Supernovae are the ultimate cosmic fireworks, releasing more energy in a few weeks than our Sun will in its entire lifetime. And Betelgeuse? It's set for a Type 2 supernova, a dramatic collapse where its core gives way under its own immense weight. This collapse sends a shockwave blasting outward, tearing the star apart and flinging its outer layers into space at mind-blowing speeds. If Betelgeuse were to explode, the first clue wouldn't even be visible. It would be an invisible flood of neutrinos, tiny ghost-like particles that barely interact with matter. These neutrinos would escape the collapsing core hours before the explosion becomes visible, giving astronomers an early warning that something epic is about to happen. Then comes the main event. When the shockwave reaches the surface, Betelgeuse will detonate in a brilliant burst of light and energy. The explosion will be so intense that for weeks it could outshine the full moon, casting shadows at night and even being visible during the day. The astronomical world is buzzing with excitement over the fate of Betelgeuse. As Dr. Emily Thompson from UC Berkeley puts it, Betelgeuse is a ticking time bomb, and we have the rare privilege of witnessing its final moments. If this red supergiant does explode in a supernova, it would be a once-in-a-lifetime event, offering an unparalleled chance to study the death of a massive star in real time. Such a spectacle would be a scientific jackpot, revealing new insights into stellar evolution, nuclear physics, and how elements that make up planets and even life are forged in the cosmos. But in a surprising twist, Betelgeuse threw astronomers a curveball. Instead of continuing to brighten, it suddenly began to dim in late 2019, so dramatically that even backyard stargazers could see the difference. The star faded to just 40% of its usual brightness, leaving scientists scrambling to uncover what was happening. Could this be the long-awaited signal of an imminent supernova? Or is something else at play? This mysterious behavior has only deepened the intrigue. As new observations pour in, astronomers are racing to piece together the puzzle before Betelgeuse makes its next move. Whether it's on the verge of an explosive finale or just experiencing an unpredictable phase, one thing is certain: Betelgeuse is keeping us all on the edge of our seats, reminding us that the universe still has plenty of surprises up its sleeve. In late 2019, astronomers were caught off guard when Betelgeuse, one of the brightest and most familiar stars in the night sky, began to fade dramatically. A star that had shone steadily for centuries was now visibly dimming, leaving scientists scrambling for answers. Some speculated that a cloud of dust had drifted in front of it, while others believed the star was undergoing a massive surface upheaval. But the true cause remained a mystery. Determined to uncover the secret behind this unexpected change, astronomers focused their most powerful telescopes on Betelgeuse, hoping to find clues hidden in its light. The Very Large Telescope in Chile captured a stunning series of images that provided a game-changing revelation. Betelgeuse was no longer the perfectly round star scientists had known. Instead, it appeared lopsided and distorted, almost as if an unseen force had reshaped it. But the surprises didn't stop there. As researchers analyzed the data in greater detail, they discovered something truly remarkable: an immense shockwave rippling across Betelgeuse, moving along our line of sight. This was no ordinary stellar fluctuation. It was an unprecedented event that hinted at powerful and mysterious forces at play beneath the star's surface. Shockwaves in massive stars like Betelgeuse can be triggered by violent internal processes, such as deep convective currents or sudden releases of energy caused by shifts in the star's core. In this case, the detected shockwave suggested that Betelgeuse was undergoing a dramatic structural upheaval, possibly linked to a major internal instability or even the buildup to a more significant event in its late evolutionary stages. To grasp the significance of these discoveries, let's first understand the photosphere, a star's visible surface where its light is emitted into space. Scientists had long believed that Betelgeuse's photosphere remained relatively stable, with only slight variations over time. But the VLT images revealed a startling truth: the star's photosphere was expanding, making Betelgeuse appear larger than ever before. It was as if an unseen force was inflating this red supergiant, causing it to swell like a cosmic balloon. As astronomers rushed to interpret this phenomenon, they identified two more peculiar changes that deepened the mystery. Around mid-November 2019, just as Betelgeuse's dimming event peaked, they observed that the star's southern hemisphere had darkened dramatically. Once as luminous as the rest of the star, this region had suddenly faded, suggesting an unexpected disturbance on its surface. At the same time, researchers recorded a sharp drop in Betelgeuse's surface temperature, which usually burns at 3,500 degrees Celsius or 6,332 degrees Fahrenheit. In just a few months, the star had cooled by several hundred degrees, an unusually rapid shift for a red supergiant. To understand why this is so unusual, we need to look at the nature of red supergiant stars. These celestial giants are in the final stages of their lives, having exhausted their hydrogen fuel and begun fusing heavier elements. As they expand to sizes hundreds or even thousands of times larger than our Sun, their outer layers cool, making them appear red. However, temperature fluctuations in red supergiants typically occur gradually over years or even decades. The fact that Betelgeuse's temperature dropped so quickly suggests that a sudden dramatic event disrupted its natural balance. As astronomers pieced together the evidence, they arrived at a shocking conclusion: Betelgeuse had likely undergone a massive surface mass ejection. These events occur when a star expels a significant amount of its outer layers into space, much like a stellar-scale volcanic eruption. While theorized for years, no one had ever directly observed an SM on a star like Betelgeuse before. The implications were profound. If Betelgeuse had indeed experienced an SME, it suggested that the star was far more unstable than previously thought. Could this be a sign that Betelgeuse is nearing the end of its life? Or is there an even deeper mystery at play? Beyond raising new questions, the SME also provided an unparalleled opportunity for astronomers. By studying this event in real time, they could gain fresh insights into the life cycles of massive stars, the forces shaping their evolution, and the processes that drive stellar death and rebirth. This was the universe at work, recycling itself on a grand scale. But what if Betelgeuse's dimming was just the beginning? Imagine a colossal star, many times the size of our Sun, suddenly ejecting an enormous cloud of gas and dust into space. This massive eruption would send shock waves rippling through the cosmos, forming a dense cloud that temporarily obscures our view of the star. Could this be a one-time event, or is Betelgeuse preparing for something even more dramatic? The mystery deepens, and the race to unlock its secrets continues. The sheer scale of Betelgeuse's surface mass ejection is staggering. Astronomers estimate that the star expelled 400 billion times more material than a typical mass ejection on other stars. To put it into perspective, the amount of material thrown off was several times the mass of Earth's moon. If all this ejected mass were gathered into a single mountain, Mount Everest would seem like a mere pebble by comparison. Despite the uncertainty surrounding Betelgeuse's future, its current state presents a rare opportunity. By studying its dimming and the massive SME, astronomers can observe a star's surface directly, offering valuable insights into the late stages of stellar evolution. This research has implications beyond Betelgeuse itself. Understanding how aging stars behave can help scientists interpret data from distant stars and exoplanets, shedding light on their compositions, atmospheres, and even potential habitability. Furthermore, studying stars like Betelgeuse enhances our knowledge of galactic evolution, particularly how heavy elements, the building blocks of planets and life, are distributed throughout the cosmos. As astronomers continue unraveling Betelgeuse's mysteries, another groundbreaking discovery has emerged: the first ever observation of a star consuming a planet. Located 12,000 light-years away in the constellation Aquila, this dramatic act of cosmic cannibalism was detected using state-of-the-art instruments and cutting-edge analysis techniques. By measuring subtle shifts in the starlight during the event, scientists were able to reconstruct the process in unprecedented detail, offering new insights into the violent interactions between stars and their planetary systems. This remarkable discovery paves the way for deeper exploration into the formation and evolution of planetary systems, potentially offering insights into the distant future of our own solar system. The ongoing study of Betelgeuse and other cosmic phenomena highlights the dedication and ingenuity of the astronomical community. With each advancement in technology and observation, we move closer to unraveling the universe's greatest mysteries and understanding our place within it. And that's it. From Betelgeuse's massive eruption to stars devouring their own planets, the cosmos never ceases to amaze. As we uncover these stellar mysteries, we inch closer to understanding the universe and our place within it. Thanks for watching Spaceverse. Until next time, keep looking up.